Hello everyone. In this video we are going to demonstrate how to use the RCF-3D application. For this you need to have a Python environment configured with the prerequisites of the software, and after that you go to the directory where you have the files, and you type streamlit run and rcf3d.py. Once you do that, the program will start a local server. Usually it's in the address that you can see here. You can also use in your local network. It will also provide an address. And once you are doing that, you are greeted with this tab. And the first tab, you are going to input the information about the geometry. In this case, it will ask you to give a name. We're going to call this building 1. And after you do that, it will ask you to enter the coordinates of your model. In this case, we are going to do this model that we have here. And as you can see, there are 2 spans in the x direction and 3 spans in the y direction. The x spans have 8.6 meters, the first one, and 4.0, the second one. And as you can see here, you have to enter the coordinates in absolute values. As you can see 0, 8.6, and the coordinate of the third node, which is this one, is the sum of these two, which is 12.6. You do the same for the y coordinates. As you can see here, it's 7.3 each span. So here you have 0, 7.3, 14.6, and 21.9. We'll also ask you the story heights. In this case, we're going to do a 5-story building. Each building has 3 meters. 3 meters. So basically, you have 0, 3, 6, 9, 12, and 15. Subsequently, it would ask you the masses in per floor. So here we have 210 tons. And after you do that, you click Create Model. It will create the model, and you can move to the Materials tab. In this case, we are going to have 3 different columns in our building. You have the green columns, red columns, the blue columns, and the beams. And here, for this case, we are going to define the first material. We're going to call it C28, which is concrete of 28 megapascals, an easy way to identify this. It will also give you the option to define the detailing level. It has 3 options, which are special detailing, intermediate, and pre-code detailing. Special detailing is consistent with the special detailing requirements of the ASE or the ACI 318, and it uses as materials a separation of the stirrups of 6 times the bar diameter for the definition. Once you do that, you click Add Material, and it will define the material in your set. We are going to use this material for both columns and beams. And after you've defined the material, you can move to the Sections tab. We're going to define 3 sections for the columns and 2 sections for the beams. The first are the green columns that you can see here, which are 80 by 60. So we're going to call them C80 by 60. So these columns have 80 centimeters are 80 centimeters height and 60 centimeters of width. And we're going to use a cover of 5 centimeters. You can select the materials, and we're going to add 24 number 6 bars, which we are going to distribute as 8 on the top, 8 on the bottom, and 8 on the sides. So Here you have 8 bars on the bottom, 8 bars on top, and 8 bars in the middle. Remember that these middle bars are additional bars, so basically it's 4 additional rows of 2 bars per row. It's number 6 bars, so which are 6/8 of an inch. So we click add section, and as you can see here, you can see the detail of the section that you just created. Then we have a 70 by 60 column with which has 22 bars. So basically, we are going to have two less bars compared to the previous section. We are going to remove them from the middle and add section. As you can see, it also shows you the recently added section. And finally, we have for the columns the third column, which is a column with 20 bars, number 6. So we define this here. We make sure to change the name, and we have our columns already defined. Now we are going to add the beams. We have 2 beams, which we're going to call B 40 by 60. So is the first beam that we have, 40 by 60. Um, which has 40 centimeters width, and it has 6 number 6 on top and 4 number 6 on the bottom. So on top we have 6 number 6, for have no middle bars, and for bottom for number 4 bars at the bottom. We maybe should do 5. So let's fix this here. Let's do 5. Okay, so once we add this section, we are going to add another section which has 50 by 30, and it has 5 number 5 on both top and bottom. So we're going to do that and click. Oh, it prompts a name, as you can see here, when you have a duplicate entry for the name. So make sure you input the different names for each section. So it now is correct. So now we move to define the columns. And here, what is important is that as you can see, it first asks you to enter the columns with the x-axis equal to 0. So basically, it's asking you to enter these columns which are here, which is why you have 4 of them. Since we are going to define the 80 by 60, it's already correct. Now it asks you for the second one, which corresponds to the 70 by 60. So we are going to change that, which are the red columns here. And finally, the blue columns, which are 60 by 60, which are the last ones. So now you can easily copy this to all floors. So we're going to copy this to all floors and click copy configuration. So it copied the configuration to all floors. Now go to the beams, and as you can see, we have the blue beams are the larger ones. So it's the first ask you the ones in the x direction. So we will input B 60 by 40 for all of them. Here you have to keep in mind that in case that you have different beams, you first will input the beams in the first span, which is the one that goes from 0 to 8.6, as you can see here. But in this case, it is not necessary because all beams are equal. But it's important to keep in mind when you have a project which has different beam heights in case that that is your case. After that, you click copy configuration to all floors because we are going to have all floors equal. Now we will define the beams in the y direction, which in this case, you first enter the beams in the first x axis, which corresponds to 0, then to the second one, then the third one. So now all beams are the same again. So we're going to input here B50 by 30. So you have this, and since all floors are the same, we are going to copy the configuration to all floors. Um, as you can see here, it shows you the assignments to each of the sections for you to check. Keep in mind that if you have a high resolution screen, you may have the axis a little bit distorted here. As you can see, 12 meters are significantly less than the 21 here, but just look at the scales, right? And it depends on your screen also. Uh, as you can see, columns are correctly assigned. You can see here the three columns on this axis, the three on this one, and the three on this one. And the beams are also correct. Once you have that, you can check also by floor. In this case, all floors are similar, so we are not going to check. After that, you hit create elements, and elements are created. Next, you move to the slab tab, and on the slab tab, you can choose to create or not create the slab. In this case, we're going to create the slab. Let's say 20 centimeter slab. Also, you can enter here the concrete strength of the slab, and it will automatically compute the elastic modulus. Keep in mind that this modulus is based on a formula that works for Colombian concretes, which is slightly lower than concretes or the formula based on the ASC 318. So keep that in mind. We're going to use 21 megapascal concrete for this, and we hit create slabs, and all slabs are created. And next, we are going to enter here the loads for the beams, and after that, we can apply the loads. It allows you to enter loads for beams in the X and the Y direction independently, and also if you want to have a different roof load, which is frequent in some cases, you can do so. I will leave the defaults and apply the loads, and after that, it allows you to save your model in case that you can later that use with some of the library functions that we have here for more advanced types of analysis that you may want to do. So make sure you save your model. If you click save your model, it will save to the same folder, but on the models folder, and the extension is pkl, which is a serialized Python file. Next, we can perform the model analysis. By default, this performs 2 modes per floor. You may want to run them, and it shows you the periods and all the analysis based on the a complete model report that you can see if you want. Then the next tab is gravity and pushover. And there, you first, in order to run the pushover analysis, you need to run your gravity analysis. So basically, you click gravity, run gravity analysis. Then it will ask you which direction you want to perform the pushover, which one is your target displacement, your displacement increment that you want to use for your models, the tolerance of your model. keep in mind that if you are running a big model, you may want to reduce your tolerance, because the larger the number of degrees of freedom of the model, it's harder to find a convergence if you use a tolerance that is too small. Um, Also, keep in mind that you may want to use a small increment in order to ensure convergence. So I'm going to use the defaults here for a roof target of 2.5% of drift ratio. Let's use two for the analysis to run faster. So you click Run Pushover Analysis, and it starts running the pushover analysis. You can check in the console that it is running all the steps, and it shows you which step it is going. And you may want to wait, and let's wait a second in order for it to finish. Sometimes when you use a really large value, it may take a while. So make sure you configure it properly and to experiment with your model. So when it finishes, it will display interactive visualization. Here you can go look at the specific values for your model. You can download it, you can make zoom, and this will be uh, the results for this model. Overall, this concludes the demonstration of the application.